Hello everyone, I'm Samidha Varvikar. Today we are going to have an exciting practical session on disk imaging and analysis. So as you know, in our previous videos, we have been learning about computer system, computer architecture, file system, disk structure and storage concepts. So today we are going to apply that knowledge in practical settings. In the first part of our practical session, we will focus on disk imaging, and for that purpose, we'll use FTK Imager tool to create a disk image. In the further second part, we will shift our focus on analysis and recovery. For that, we will use autopsy tool. Before that, we will see what is disk imaging, hashing, methods of imaging, and tools. So our first point is imaging. So as we know, the basic principle in digital forensics is to never work on original evidence. So imaging is the process of extracting the data or information from digital storage media like hard disk, USB devices. It's a bit by bit file that's an exact unaltered copy of the media being duplicated. It prevents tampering with original data evidence. So imaging basically means extracting the data from different storage media. In this process, a bit by bit data is copied from the source media to the destination media. Source media includes hard disk, pen drive, live memory, that is random access memory, some files and folders. That is different types of storage devices. This process is done at the beginning to ensure that the evidence is prevented from any kind of tampering and modification. So image is the exact mirror copy of the storage media. Next we will see hashing. So before analyzing the evidence, its verification should be done, and it is done by calculating hash value. So it's an important step in digital forensics process. Hashing is the process of applying an algorithm, mathematical algorithm, to a file or storage media for creating an alphanumeric value, which is basically called as a hash value. This value is unique to each file or storage media. So that's why it is not possible to alter evidence without changing its hash value. So if the evidence is altered, then the hash value doesn't remain the same. So we can identify from that if the evidence and the created image both are identical or not. Next we'll see methods of imaging. So there are two types, physical image and logical image. Physical image, it is a complete image of all the contents of the storage media, means it is an exact copy of the hard drive. It also captures the deleted space, file fragments on the data, and it provides access to the encrypted data also. Logical image. It is, as its name, it is a logical image of hard drive, means it captures only active data which is present on the drive. It doesn't capture any deleted files. It only captures the files which are visible to the user. We'll see this further while creating the image using FTK tool. So next, tools. For imaging, we will use FTK, that is Forensic Toolkit, and for analysis purpose, we'll use Autopsy tool. So these points were important in order to understand the practical session. So we will start with the first part, that is imaging of the tool of the disk, and for that purpose, we will use FTK Imager. So now we will see how to use FTK Imager to create image of a storage media. So FTK means Forensic Toolkit, which is basically used for creation of an image and for the analysis purpose. So first we'll see how to download FTK. Visit this site, Access Data FTK Imager. Go to Downloads. And from here, you can download the latest version of Access Data FTK Imager. So I have already downloaded this tool. Now we'll see the installation. This is the installation wizard. Select the browser where you want to install this software. So the installation is done. So first we'll understand the interface of this tool. So this is the menu bar, which contains four menus: file, view, mode, and help. This is the toolbar, and these are the view panes. So file menu, it provides different options like adding an evidence item, adding attached devices on the machines, image mounting. Image mounting means mounting an image using this software. So that mounted image acts as an whole drive which provides read-only access, and it allows us to browse its contents. So we'll use this option for today, that is create disk image, for creating image of an storage media. Capture memory option is used to capture the live memory, that is random access memory. Next is view mode. It allows to customize the appearance of this tool. Next it is mode. It allows us to select the preview mode for this tool. And help menu provides user guide. So this is the toolbar. It shows same options like we have seen in the file menu, that is adding an evidence, adding attached devices, creating an image, capturing the live memory, user guide, and so on. Next is the view panes. So basically there are four view panes: evidence tree, combination pane, and file list. So evidence tree, it displays the evidence item in hierarchical tree. File list, it displays the files and folders in the evidence which we have selected currently. Next is combination pane. It includes three tabs, that is property tabs, hex value tabs, and custom content tabs. So the property tabs, it includes information like the type and size of the object. Hex value, it basically converts the hexadecimal value to decimal. And the custom content source tab, here the each added item is appeared in this pane. So for today we'll be using the option of create disk image. So this is the source evidence type, from which given options we have to select one source type. So here the mentioned types are physical drive, logical drive, image files, contents of a folder, and Pernico device, that is CD or DVD. So as we have seen in our PPT, the difference between physical image and logical image. So physical image, it captures all the contents of the hard disk or the storage media, while logical drive, it captures only the active content, only those which are visible to the user. Image file means it is of a particular file. Contents means contents of a folder. In this we can select a particular specific folder for which we want to create an image, and here we can select any CD or DVD drive. So today we'll be choosing the physical drive. We can see this from here in the disk management. See, this is the physical, both of these are the physical drives. One, it includes this part, one of this includes the partitions. These are the logical partitions of the physical drive, and here I have connected one physical device, removable device. So today we'll be creating an image of this removable device. So for that we'll select physical drive. So we'll select the source drive. So here it is, USB SanDisk. Click on fix. Next you have to add the image destination. So these are the file formats or image destination type. Raw, it is common format which is used in almost all devices. Next it is a smart. Smart is used in Linux based devices. E01, it is a particular software related format, and AFF is also open source software related format which was previously used. It is now not used now commonly. So today we'll use raw format. So here we have to enter the evidence information. So today we'll use some random information for this purpose. So first you have to enter the case number. Next it is evidence number. Description of that evidence, that is imaging of USB drive. You have to enter the name of examiner, notes for testing purpose. So after filling all these details, click on next. So here you have to select the destination folder where you want to save the particular image. So I'll basically create a new folder here. You have to enter the file name without the extension. So these are the important points, that is image fragment size. So if the hard disk is huge in size, means if the hard disk size is more, then you have to choose the fragment size here. Means by choosing this, it basically splits the image in different segments. And compression, if you want to compress the image, then you can choose this option. Next, click on finish. Here are some options like verify the image after they are created. So basically check this option and click on start. So see, the image is being created here. We'll also see it in folder where we have saved it. See, the image is being created here. So it will take time to create an image. So the image is being created and now the verification process is going on. We can see here the image summary, which includes the version of the FTK imager, the case information, where the particular image is being saved, and the hash value. And these are the different segments in which the image is divided. So as we have seen while creating the image, there was an option of image fragment size. So this image is divided into different segments of a particular fragment size. So the image has been verified and these are the verification results. So here the hash value is being displayed. computed hash and the report hash. So both these hash values are identical, hence it's showing the result as match. It also shows the details such as about the bad sectors. So no bad sectors are found here. So this was all about creation of image of a particular storage media. So we have used FTK Imager tool for that purpose. In our further session, we'll see how to analyze the image using autopsy tools. And also we'll learn about file recovery. Thank you.